Hello everyone, this is Ruai PCB, your trusted PCB partner. Today we will introduce the layers used in designing single-sided PCBs. The layers used for drawing single-sided PCBs usually consist of the following 5 working layers. Layer 1, top layer, which is the top copper. Copper trace layer, also known as the top trace or simply the top layer. The system default color is red. Here I only drew one trace. In double-sided boards, this layer represents the top copper trace, while in single-sided boards, it indicates jumper wires. I specifically drew one to demonstrate the jumper wire. As for how to use this jumper wire, we already covered it in the previous episode. That is, if the length isn't too long, we can use a bent silver paste resistor for soldering and pressure reduction, then insert it into these two pads and solder it to form a jumper wire, connecting this circuit as needed. Next is the bottom layer, the bottom copper trace layer, also known as the bottom trace or simply the bottom layer. By default, the system uses blue, which is the main color for our PCB. Both the traces and copper core are blue. This represents the bottom layer routing. This layer represents the soldering side of the circuit board, including the copper pads and vias, as well as the copper traces, but it does not include the pads and vias themselves. In other words, pads and vias are not considered part of the top or bottom layer. Let's take a quick look at its 3D effect. That is, there are no traces or copper core on the top layer, but there are on the bottom layer. So you can see these yellow pads are mainly concentrated on the bottom layer. This is because it's displayed as a double-sided board, so the top layer also appears to have them, but in actual manufacturing, these yellow pads do not exist on the top layer. For a single-sided board, only the bottom layer has these features. Next, the top silkscreen layer, also called the top silkscreen or simply the silkscreen layer. By default, in KICB, the system uses yellow, and in most other software as well, yellow for the top silkscreen. Single-sided boards do not have a bottom silkscreen. For double-sided boards, the bottom silkscreen is usually shown in green. This is equivalent to the top layer of the finished circuit board, showing the silkscreen outlines of components and their reference designators. We can take a look like these two 12s here and the boxes below. These indicate the positions of the components, the outlines and such. This is what the silkscreen layer is. Next is the cap-out layer. In KCB, it's not called the cap-out layer, it's called the cut layer. This layer is used to define the outer frame. Its name is generally called the keep-out layer, and it's present in most EDA software. KICB has a specific name for it, and in KICB it's shown in white, while in most other software it's purple. This layer is actually a virtual layer. In most cases, it's used to define the shape and size of the circuit board, just like the outline of our PCB. Rather than calling it a layer, it's more accurate to say it's a frame. Most of the time, it's used to draw the outline or the border of the PCB, which definitely needs to be drawn with this. For internal slots, sometimes this layer is also used, but in some software, there are dedicated slot layers, so there are some differences. It plays a significant role. It's not just used to define the dimensions of the PCB, and if there is no such frame, automatic routing can't be carried out properly. As we mentioned earlier when talking about automatic routing will only route components that are within the cut layer in KiCad. For anything outside this frame, it won't perform automatic routing on it. So, how do PCB manufacturers define the board outline? Some manufacturers don't require the keep-out layer, some require the use of the mechanical layer, and some even have a dedicated board outline layer. In short, different manufacturers have different requirements. This is something you need to check with the manufacturer you plan to use to see if they have any special requirements for this. Most manufacturers do support it. The cap-out layer is used to define the board outline. However, it's still important to communicate this in advance. If you don't clarify beforehand, there may be cases where the slots you drew using this layer end up being invalid, which can happen. And then the last layer is the composite layer. In KiCad, the composite layer displays the areas occupied by pads and vias, and it shows them in the same color as the top and bottom layers, red on the top layer and blue on the bottom layer. In other software applications, this particular layer is typically represented as a gray color. In the context of both single-sided and double-sided PCB designs, this specific layer comprehensively includes essential components such as vias and pads, as well as certain traces and protrusions that are present on that particular layer. This is because single-sided boards inherently possess pads and vias exclusively on their bottom layer. For double-sided boards and for multi-layer boards, each layer will have pads and vias, which is why it's called the composite layer. With single-sided boards, you can't really see the composite aspect because there's only one layer. But with double-sided and multi-layer boards, you can see that it's composite since it's present on every layer. For single-sided boards, there's only one composite layer, which is actually just the bottom layer, so for single-sided boards, there's no difference. Double-sided boards have two, and multi-layer boards have multiple composite layers that connect the vias and the pads, essentially linking different layers together. So the composite layers in multi-layer boards are very different from those in single-sided boards. So what we've just introduced are the working layers needed for a single-sided board, which are actually the system's default layers required for drawing a standard double-sided PCB. The only difference is that the top layer is specifically defined as the jumper wire layer. Alright, that's all for today's content. If you enjoyed this video, please subscribe to my channel for more videos. Thank you, everyone.